Hello everyone, I hope that you are doing well. In the last videos we have learned about MPTCP, what MPTCP is and how we can use it in our systems. In this video we are going to elaborate a little more on MPTCP and we learn how it functions. MPTCP is an extension of TCP with this main difference that it can have more than one path or more than one subflow in the same connection. But it is not possible in conventional TCPs. In conventional TCPs, we have only one connection, one path, and that's over. When the client and a server want to have an MPTCP connection, they use a three-way handshake that it is common in TCP. In TCP, when a client and server wants to start a connection, the client sends a SYN packet to the server. It means that I want to start a connection with you. The server answers with a SYNAC packet. It means that, okay, I'm ready. And finally, the client asks the server and they start data transmission. In the MPTCP connection establishment, when the client sends the SYN packet, it includes a MPTCP capable option. It means that, okay, hey server, I want to make a connection with you, but it is MPTCP connection. I want to have multi-passing connection with you. In this case, if the server is supporting the MPTCP connection, it answers, it responds with SYNAC containing MP capable too. It means, okay, I am supporting MPTCP too, so let's have the connection by using a multi-pass or MPTCP protocol, and the client asks the SYNAC packet so the data transmission can be started. In the next step, if the client to establish another connection, for example, your mobile phone was using only Wi-Fi, now it wants to have LTE and it wants to use MPTCP protocol to access to the server by using Wi-Fi and LTE at the same time. In this case, client sends a SYN packet which includes MP join. It means, hey server, I want to add a new subflow. I want to add a new path, for example, which is LTE or 5G or other thing. Server says, okay, that's okay, SYNAC MP join. Let's have it. And client exits. So in this way, the connection between client and server by using two subflows can happen. For example, if you look at the Wireshark, which is I'm going to talk about it a little more in a couple of minutes, you can see SYN, SYNAC, and ACK with the client and server by using MPTCP protocol. But after the connection, how MPTCP works? MPTCP has a component called scheduler, which is responsible for choosing the right subflow to transmit the data. For example, this is the application layer, which is in the user land. It wants to make a connection with, for example, with the server. It is creating the TCP. It is creating a socket, and we are using MPTCP. And now we want to send some packets. The scheduler, based on some criteria, looks at the subflows and then choose the right subflow to send the packet. For example, at this moment, for sending P1 packet, choose the subflow. Then when P2 is arriving, again it checks, for example, it is choosing the same subflow or the other one based on its strategy to send the packets. At the receiver, packets maybe can be delivered out of order because the latency for the subflows can be different. So at the receiver, the packets are reordered and delivered to the application layer. Okay, so the responsibility of the scheduler is choosing the right subflow at the moment. The default scheduler that is being used in the Linux kernel is called the lowest RTT. It looks at the available subflows, the subflows that can carry information, and chooses the best one based on the RTT that is the lowest. For example, if the RTT, if both are the subflows are available, it means that they have some space in the receive window or congestion window, and this RTT for this one is lower than this one, so it chooses this one as the transmission subflow. After choosing the subflow, for example, this is the socket and the scheduler is here, and it has chosen R0. The congestion control component is the responsible for adjusting the sending rate for that subflow. So the scheduler chooses the subflow and congestion control is adjusting the sending rate. There are two different congestion control mechanisms, coupled and uncoupled, in MPTCP. In the uncoupled versions, the adjustment is done without considering the other subflows, so it can damage the fairness. But in the coupled mode, the adjustment is done by considering the other subflows. This is because of the fairness, and this can benefit the fairness. So, in a nutshell, a scheduler is choosing the subflow, and congestion control is adjusting the sending rate, is controlling the sending rate for the selected subflow. Let's see the functionality of MPTCP on the Wireshark. This is the Wireshark for a connection. As you can see, client is sending SYN-ACK. I am sending this SYN-ACK, SYN packet, which is MPTCP protocol based. The server is answering, and the client is acting it like I told a couple of minutes ago. If we go to the transmission control protocol, over there we can, let me close them. Okay, over there we can see some common information for the TCP. For example, the source port is 47,812. The destination port is 80, which it shows that it is HTTP. There are some other information. For example, the sequence number is 0 in Wireshark, but the raw value is a different thing, and the Wireshark is helping us to understanding better by having a relative sequence number and some other stuff that you can see. In the flags, you can see that the flag for SYN is set, which is showing that this is a SYN packet. The most important part is here, the options. This is the field that the information for MPTCP can be carried. There are some other stuff here. For example, the SAC is permitted, the window scale is permitted, and it is multiplied by 128. But we need this part. Multipass transmission control protocol, multipass capable. If I open this, you can see MPTCP information over there. For example, the version is 0. We have two official versions, 0 and 1. This is the 0 version. We can see the exchange key for the sender here, and you can see some other information. So the stuff for MPTCP is carried in the options field of TCP. And you can see this information in Wireshark. So what about changing scheduler and congestion control mechanism? How we can change it, how we can see which ones are being used right now. For the scheduler and checking the current scheduler, you can use sysctl command, net, MPTCP, scheduler. And as I told you, the default one, the lowest RTT is being used. For example, I want to change it to redundant. Redundant is a scheduler that duplicates the packets and send them through all subflows. What should I do? I use sudo and the command that I used above, sysctl net MPTCP scheduler, and I want to change it to redundant. If I check it, you can see it is redundant. And if I want to change it to the default one, I will write OK default, and if I check it, it is default. About the congestion control mechanism, we can use sudo sysctl sysctl net IPv4 then TCP congestion control. For example, I want to change it to cubic. I write cubic, and if I want to check it, sysctl net IPv4 TCP congestion control mechanism, it is cubic. If I want to change it to Reno, I can use Reno. If I want to change it to a coupled MPTCP, for example, LIA, I can choose LIA. And if I check it, it is LIA. If again I want to change it to cubic, I can use cubic, and easily I can change between, I can go around between different schedulers and different congestion control mechanisms. So in this video we learned what functionalities MPTCP contains, such as, I don't know, scheduling, congestion control mechanisms, and how they are working. Then we had a look on the Wireshark and different parts of MPTCP and how TCP is carrying MPTCP stuff. It is in its option, and we learned how to change different options such as scheduler and congestion control mechanism in MPTCP.